Good afternoon to all my YouTube viewers. In this video, I like to discuss about various questions which are very important for any kind of exams. This will be very helpful to all the students. So take care of it. You will be benefited out of it. Let us start the job. Number one, why a bulb glows instantly though drift velocity of electrons in a conductor of the order of 10 to the power minus 4 meter per second. And when we switch on, electric field setups in the entire closed circuit instantly, including within the bulb filaments, almost close to the velocity of light. Now, due to electric field, free electrons get drifted in the entire circuits and current established without taking time. So it glows immediately. Next question. When current flows through a non-uniform cross section, what happens to the following parameters: current densities, electric field, drift velocity, and current? As we know that cross sections are non-uniform, so current density will be different from different position. The cross section at 2 is less than cross section at 1. So current density is inversely proportional to area of cross section. So density will be more for 2 than 1. So similarly, electric field will also change. E2 will be greater than E1 because electric field directly proportional to density. As density is more at 2, so electric field will be greater at 2. Number C, drift velocity of electron will change. Yes, according to cross section, its velocity depends. That means drift velocity of electron is inversely proportional to area. So higher will be drift velocity of electron will be higher at 2 than at 1. Now what about current? Current will be same for entire cross sections. Whatever may be the area, it remains same amount of current will flow through the entire length of the conductor. Next question 3. A piece of copper and another of germanium are cooled from room temperature to 80 K. The resistance of each, there are 4 choices. Each of them decreases, each of them increases. Copper increases and germanium decreases. Copper decreases and germanium increases. Yes, for D it is correct. Coefficient of resistivity will decrease at lower temperature for copper, but it is reverse in the case for semiconductors material. Germanium is a semiconductor, so its resistivity will increase with lowering temperature. So resistance will increase accordingly. Number 4. Identify correct combination. Full scale deflection 0 to 360 degree. For galvanometer to be converted, galvanometer will be converted to ammeter as well as voltmeter. Now full scale deflection 0 to 360 for A, and here is S for ammeter shunt resistance, that is I into galvanometer resistance Ig divided by I minus Ig. When it is converted to voltmeter, modified resistance in series, that is R, will be V divided by Ig minus capital G. Now full scale for modification, that is 0 to 180 degree, and galvanometer modified to ammeter, that is S equal to Ig by Ig into big G divided by I minus Ig, and when it is converted to voltmeter, that is R equal to V by Ig minus G. And full scale deflection for C is 90 degree to 120 degree. Again shunt is modified Ig capital G divided by I minus Ig, and when it is converted to voltmeter, big R equal to V by Ig minus G. And number D, full scale deflection here 90 degree to 120 degree, 70 degree to 90 degree for D. And modifications are for shunt Ig divided by I minus Ig, and for voltmeter R equal to V by Ig minus G. Now here the main point is deflection, full scale deflection. What should be the range? The correct range is 90 degree to 120 degree. So C will be the answer here. When range is taken some other angle, then error will be more. So best suited range is 90 degree to 120 degree. And shunt has to be Ig into big G divided by I minus Ig, as well as and for voltmeter resistance in series, that is capital R, has to be big V by Ig galvanometer current minus galvanometer resistance. Next question number 5. Now for which of the following dependence of drift velocity V suffix D on electric field capital E is? Of course Ohm's law to be obeyed. Now there are 4 choices: V suffix D proportional to capital E to the power half, and V suffix D proportional to capital E square, and V suffix D proportional, C is the choice, that is V suffix D proportional to E capital E, and next choice V suffix D inversely proportional to capital E. We know V suffix D equal to I by small n capital A small e. We can write I by M is J by NE, and J is sigma into capital E by NE. From here we can say drift velocity directly proportional to electric field. So choice C will be the correct one. Question number 6. A cell having an EMF E and internal resistance small r is connected across a variable resistance capital R. As the resistance capital R increases, the plot of potential difference V across capital R is given by. There are 4 diagrams. We have to select the correct one. For a circuit diagram, which is very simple, one battery, internal resistance of the battery smaller and bigger is the resistance in the series. Now I will be E divided by bigger plus smaller, and potential drop across the bigger will be I bigger. That means E bigger divided by R bigger plus smaller. Here bigger is the variable. Now from this relation you can see when bigger is 0, B has to be 0. When bigger tends to infinity, then big V will be equal to supply EMF of the battery. How to do that? You divide the entire equation by capital R, you will get capital E divided by 1 plus small r by capital R. When capital R is very large, say infinite, it will become 0. So expression V will be equal to capital E. So here diagram number C is correct, because initially it is 0, then gradually it will increase to maximum value will be capital E, that is the potential EMF of the battery. Now come to job number 7. In the series combination of n cells, each cell having EMF E and internal resistance smaller, if 3 cells are wrongly connected, the total EMF and internal resistance of the combination will be. Now as it is understood that wrongly connected, 3 cells are wrongly connected. Now what happens, for each wrongly connected battery will neutralize by a rightly connected one battery. So 3 batteries will neutralize another 3 batteries which are in rightly connected. That means 6 battery EMF will be reduced from the actual supply. Total supply is N into E minus 6 into E will be the net available EMF of the circuit. And internal resistance, whether it is rightly connected or wrong, it doesn't matter, it will be N times smaller. So here D is the correct choice. Ne minus 6E, and the internal resistance will be N times smaller. N times smaller. You can see N times smaller is the total internal resistance of the circuit. What is mobility of charge carriers? Mobility defined as the magnitude of drift velocity per unit electric field. That is, mu is V suffix D divided by capital E. And V suffix D, already we know that V suffix D is small e big E divided by m into tau. After substitution, mu will be small e tau by m. Expression for mobility will be small e relaxation time by small m, mass of electron. Now deduce Ohm's law from I equal to n small e a V suffix d. I mean, this is in terms of n is number of electrons per unit volume, is the charge of an electron, and A is area of cross section of the conductor, and V suffix d is the drift velocity. Now as it is known, V suffix d equal to small e big E by m into tau. Now we can substitute here and we'll get n small e square capital E capital A tau by small m. N small e square capital E capital A tau by small m. Now for a conductor of length L, we can write E equal to V by L, and that means I we can write n square A tau by small m into V by L. I equal to n square A tau by small m into V by L. Now rearranging, we can write V equal to m by n square tau within bracket, m divided by n square tau within bracket L by capital A into I. If we write down sigma specific resistance for m divided by n square tau, that means expression will be rho L by A into capital I, rho L by A into capital I. So V equal to, we can write down Ri, as we know R equal to rho L by A. So V is directly proportional. Ohm's law is proved here. Now next job, here on the basis of materials, then resistance, and then rho versus temperature plot, we have to select which combination is correct. Now here given copper, nickel, titanium alloy, germanium, nichrome. Copper, nickel, titanium alloys, germanium, nichrome, and there are a few points in terms of resistance given: good conductor, high resistance wire, very low resistance, resistance increase with temperature, resistance increases with temperature. All these points are given, and the diagrams are also provided. Now there are choices, 3 choices are given here, that is copper. First choice given copper, then good conductor, then diagram number 3. If we see this combination, diagram number 3, resistivity decreases with temperature, that is not matching with the copper material. Copper is a very good conductor, it is okay, but resistivity plot is not matching. So this cannot be the choice. Number 2, here B means nickel titanium alloy, and G means here very low resistance. Yes, nickel titanium alloy is very low resistance, but what is the diagram? Diagram is 3. Here 3 means this diagram specific resistance decreases with temperature, but this pattern is valid for semiconductor resistivity temperature plot. So number 2 choice also not correct. Now come to combination 3, D, which is nichrome, F is high resistance wire, and plot 1. If you see this not matching, because nichrome resistance increases with temperature, and high resistance, it has slightly higher resistance than normal wire, but resistance increases, that is the main property of nichrome wire. So 3 cannot be a combination, correct combination. Now come to 4, B then G. B means here nickel titanium alloy. G means very low resistance. Yes, then nickel titanium wire has very low resistance, and plot is 4. This is a superconductor plot. Resistivity decreases drastically at a particular temperature. That is the property of a superconductor. So choice D will be our answer here. Nickel titanium alloy. Next, very low resistance, and diagram 4, that is property of superconductor. Resistivity temperature plot will be this type, that at a particular temperature resistance becomes very low. Job number 11. For the circuit, find current in the wire AB, AE, BE, CE, DE. I mean, is the junction point AE, B, C, D. We have to find out. Now, let us say potential at E is V. Then, according to this diagram, we can write C, that is potential 6 volt minus V divided by whatever resistance, that is 1 volt, 1 ohm. So it will give current IC. Similarly, for AE will get 2 minus V divided by resistance is 1 ohm. So that will be the current for IAE. Similarly, for BE 4 minus V divided by 2, and for D 4 minus V divided by 2. Summing all these left hand side as well as right hand side, and sum of all the currents has to be 0, because it is meeting at the same point, it is not going anywhere. So sum of all the currents will be 0. Now solving here, we can get V equal to 4 volt. Once 4 volt is available, now putting in the respective current, we can get current, and here it is found that current will be for C 2 amperes, and for AE minus 2, for AE minus 2 ampere, and for B and D no current, because potential difference is 0. That is the point. Now come to 12. Electromotive force. What it means? What is its unit? Electromotive force is not a force as it is known in mechanics. From Newton's second law of motion, we can derive force, and from first law we know the definition will come and all these things. It is the voltage difference between the two terminals of a source for an open circuit. I mean, when battery is in open circuit, whatever potential drop available, that is known as electromotive force. Its unit is volts, V-O-L-T-S. Now job number 13. What amount of heat will be generated in a resistance coil when Q amount charge flowing through it and the current decreases uniformly in time interval T0, as it is given in the question, that current decreases to 0 in T0 time, and charge accumulated passing through the coil is Q, that is given. Now for this type of plot, I mean initially say current is I naught, after time t naught it will be 0, then it will straight line linearly decreases, uniformly decreases as it is given in the question. Now from this plot, first straightforward you can find out tan theta. Taking theta is the angle that is shown in the diagram. I naught by t naught will come. Then you know the equation of a straight line. For this it is understood gradient is negative, so y equal to minus mx plus c. C is the intercept on y axis. Now very easily, instead of a we put I naught by t naught. In x, instead of x you can put t plus I naught is the intercept in the positive side of x y axis, so I naught. Now from here this equation will be equation for current as per the given condition. Now we know the area under this graph will give the amount of charge, because I and t is there. We know q equal to I into t. Here half area is half base into altitude, that is half t naught I naught. That means q will be replaced by this one. That means q we can say half t naught I naught. We can write q equal to half t naught I naught, that I mean to say. Now from here find out I naught in terms of q, twice q over t naught. Put it in the equation of current that is already available. I will become twice q by t naught minus twice q by t naught square into t. Now from here we know the amount of heat generated in that due to this will be I square r into dt. Now put I here, then make it square, then r is the resistance of the circuit into dt time, then integrate for 0 to t naught time. Now this is a simple integration. After solving we can get step you can follow 4q square by t naught. If you take out, then 1 minus small t by t naught whole square will be there into dt. You take this one sum and so you can say it is x. Then by substitution you can get change the limit accordingly, and you will get heat generated in the coil will be 4 by 3 q square r by t naught. Now here is a circuit given. Two batteries are there. One is 24 volt, another 12 volt in the opposite polarity, and there are resistances 2 ohm, 4 ohm, and 6 ohm in series, and one in between 2 and 4 ohm earthing is done. Now for this type of circuit, first you find out current. How to get current? Simply you see the current will be 24 volt is dominating over 12 volts, so 24 minus 12 divided by whatever resistance all are in series, you will get current. That current is coming here 1 ampere, only 1 ampere. Then question is you have to find out potential drop between AB, then BC, then CA, all these things are there, CD. Now it is very easy to do. A VA minus V will give us straightforward how much current is passing through this 1 ampere, through which resistance it is going, 2 ohm. So 2 into 1, that means potential drop VA minus VB will be 2 volt. 2 into 1, 2 ohm, 1 ampere, that will give us 2 volt. Similarly between B and C, B minus VC will give us 4 into 1, 4 volt, and then VC minus VD will be 6 volt. That is a very easy way you can handle this job. But if question asks that potential you have to calculate for A, B as well as for C and D, then it will you can follow this technique. Potential at B will be 0. You start from here, that will give you much comfort. VB minus drop 4 into 1 equal to, you will reach at C, that means it will be equal to C. You know VB is 0, that means VC will come minus 4 volt. Similarly, we can start, we can start from C to D. I mean VC is known to you, that is minus 4 volt, minus drop 6 into 1, then it will be VD. That means VD will come minus 10 volt. VD is minus 10 volt. Now similarly you can find out VE also. V will be minus 22 volt, and by doing this VA we can find out 2 volt. How to find out VA? Because VE is giving 24 volt, 22 volt. VE V will be minus 22 volt will come. V will be minus 22 volt here. You can see here. V is coming minus 22 volt. Now substitute for VA. How to do that? Because V is minus 22 plus battery is there 24. That will give VA. So VA will be 22 volt. 2 volt. VA will be 2 volt. By this, in this way you can find out potential at all the points. Now come to next question. Here, if earthing shifted to position E, if it is shifted position E, find VA minus VB as usual, VB minus VC, VC minus VD, and the potentials of all the points A, B, C, D. Now what to do? Currents remain same. Current is not going to change. Wherever you place the earthing, no problem. Current will remain same because resistance is same, supply is same. So same direction current, that is 1 ampere. Next, you have to find out, as you know that earthing is done as at E, so E potential will be 0. Now 0 here plus 24 volt. You see the diagram, plus 24 volts. So VA will come 24. VA will come 24. You can see VA will come 24 volt. Then VA to VB, VA minus whatever drop, that will give VB. So VB will come 22. Then VB minus drop, again 4 volt. Then VC will come, that is 18 volt. Then VC minus drop will give VD. Then VD will come 12 volt. And VA minus VB is 2 volt. So in this way you can find out difference. Difference is very simple. Whatever resistance is there into I will give the potential drop. Okay, come to next question. Job number 16. Potential of field given by V equal to A small a within bracket x square plus y square. Here A is a constant. X and y is the variable for electric field. Now we know the basic formula for electric field E equal to minus dV by dx I plus dV by dy j plus dV by dz k. But here only x y is available, so we have kept dV by dx I and dV by dy j only. Now as given V equal to A within bracket x square plus y square, that means dV by dx we can differentiate this one, it will give twice ax. Similarly for dV by dy twice ay, substituting we can get minus twice ax I plus twice ay j. We take out twice a minus twice a within bracket xi plus yj will be coming. Next job. Now potential versus x plot is given. Draw a graph for E versus x. A potential plot is given here. You can see that initially potential will be lower to 9 volt. then it will be parallel to x-axis, and then it will rise, then it will be coming down to 0 again. Now from here, as earlier equation we have seen, dv by dx is minus e. I mean, if gradient of dv by dx is coming negative, then electric field will be projected to positive side. If dv by dx is positive, then electric field will be negative, vice versa. Now here you can see, by seeing itself we can understand this is a negative gradient, and that means electric field will be positive. What is the value here, dv by dx? It is minus 3 will come dv by dx. As we know, dv by dx equal to minus e, so minus minus cancels, so it will give 3 volt per meter, that is electric field. So at position A, you can see corresponding point here, A will give a electric field E value. This line will be a dotted line. This line has to be a dotted one, like this, and there is a mistake. So this will be, up to this it will maintain same electric field. Then from here to here no gradient available, so it will be 0 here. Then come to this side, you see the totally positive gradient here. This is a positive gradient. So here is a mistake. Please be noted that there was a mistake. I have corrected it. Now for this negative gradient, you can see, for this negative gradient we got a positive electric field, and here no change in gradient, so it will be 0. Now you see positive gradient from here to here, I mean up to 5 meters, then its value will be minus 10 volt per meter. It will come not in this side, it will come this side, because positive gradient means, you can see the equation here, dv by dx equal to minus e. So if dv by dx is itself positive, so electric field will be negative, it will come this side, and these are the dotted lines, should be dotted line. Now come to other part, here, from here to here, negative gradient. So we will get positive value of electric field. That amount will be most probably 7 or 3, something. You have to calculate, find out the gradient. Here is 21, here is 0, dv is 21 divided by this is 3, 7 volt per meter. It will be, this magnitude will be 7 volt per meter. This is a very good job, but due to some reason it was mistake during plot. Now it is corrected. I can repeat once again. This is a negative gradient, you will get positive value of E. Then here it is 0, no change in potential. Distance changes, but potential is not changing. Here potential is dv by dx is positive, that means electric field will be negative, minus 10 volt per meter. And here negative, that means it will be ulta, just on the other side, that will come 7 volt per meter. Now come to job number 18. The potential difference VA minus VB between the points A and B for circuit segment shown in figure at the given instant is. Here shows at point A, and the right side it is point B, and there is a battery, then 2 ohm resistance, then a capacitor. The left side is negative, right side is positive, and then another resistance 3 ohm, then position B. Now you have to find out VA minus VB. Then how to start? As current direction is clearly given, so we can start like this. VA, my battery is opposite, so minus 6 volt, minus, because there will be a potential drop along the direction of current here, So here 2 ohm into current 3 ampere, so 2 into 3, and capacitor shown in opposite direction. So here we can do this will act as just like battery, negative to positive, like that. It will be 9 microcoulomb divided by 1 microfarad. Micro get cancelled, coulomb by Faraday will give volt. That means 9 volt will be added here. Minus, again drop on the resistance, that is 3 into 3, and we will reach at position B, that means equal to VB. Bring VB left side and all other towards right side. It is giving 12 volt. Now another circuit is shown here. There are 3 resistances, all are connected with the earth. There is a capacitance and battery is there, that is also connected with the earth. Battery supply is V. As it is seen from the diagram, it is understood that all 3 resistances will be parallel in connection. Combining, it will give R by 3, and capacitance is there. As soon as switch will be initially its charge, the charge on the capacitor as a function of time, you have to find out. I mean, switch is closed at t equal to 0. The charge on the capacitor as a function of time is given by. Now we have this is a charging process. I mean, as soon as a switch will be connected, immediately battery will provide charge, and it will charge the battery, charge the capacitor, and current will pass through the circuit. Now for this, as it is known that the charging process takes place by this method, that is Q equal to Q naught is when it will be totally charged. Capacitor fully charged means Q naught within bracket 1 minus e to the power t by tau. T by tau. Tau is the relaxation, time constant. Tau will be here, time constant. Then bracket close. Now here, as it tau C, we can find out that is capacitance, equivalent capacity, single capacitance is there, that means C is here, and resistance is equivalent, that is R by 3. That will give the time constant for the circuit. Then Q will be Q naught within bracket 1 minus e to the power t divided by tau C. Tau C will be CR or RC divided by 3, that will come in the numerator and then bracket close. So this is this will be the answer. Choices are not written. This will be the answer for this question. Now another circuit is shown here. There are 3 capacitors, and capacitances are given, and supply at each point, position A, B and C is given, potentials are given. We have to find out the junction point potential. How to do that? Very simply we can do that. Say Q1 charge will induce 2 minus Q1, then a same charge will be shared by 2 other capacitors, that is Q2 and Q3, plus Q2 plus Q3. That means according to charge conservation, Q1 equal to Q2 plus Q3. Now from Q1 we can write 60 into potential drop, that means 6 volt minus V into 60 microcoulomb, that will come in the left side, equal to for the other 2 capacitors, that is V minus 2, because it will charge both the capacitors, that is V minus 2 into 20 capacitance, 20 microfarad plus V minus 3. V assumed to be greater than this, that was the assumption. Now into 30 solving here, we can get V equal to 49 by 11 volts. Yes, it is the answer for this question. Thank you very much for all the aspirants, those who are appearing for the exams. They should prepare all the videos several times. Seeing only once, they may hardly get 30 to 40%. One day or 2 days later, they will see they cannot solve the problem. Seeing is not enough. Once you can solve first time, that means you have done only 50% achievement. Do few more times, then you can achieve up to the level of 95%. Simply single time solution means you may be thinking I can make up it at exam hall. You cannot make up it, because you are going to fight the toughest competition in the world. Competition level of this country is very high, so once you have to target something, you have to prepare at a different level. At that mode you have to keep yourself. This is my advice from my side. Thank you very much for listening. Prepare, practice, and practice you will gain. There is no chance to lose anything. If you like this, you like it, also share others, so that other people are getting help, means God will help you also. Thank you very much to all of you.